So today we're going to be making an amortization table. In an example, where we're making increasing contributions in geometric progression. All right, so in this example, a company has taken out a loan of $750,000 to be paid off in 3 years. So therefore, our future value must be $750,000 because that's how much we need to have 3 years' time from now. The financial manager of the company decides to establish an amortization fund, increasing the payments by 15% each year. If the money invested earning a 10% interest per annum compounded annually, determine the value of the first payment and prepare the table for the amortization fund. Okay, so first thing I'm going to do is I'm just going to write out everything that we know. So we know the future value, right? The amount of money that we need to have 3 years from now is $750,000. So that's going to be our future value. Okay, then our time is going to be 3 years. 3 years time, we need to have this all paid off. Then G is the gradient, so that's going to be 15%. And then I is the interest rate, which is 10% per year, so we can just say 10%. We don't actually have to adjust any of these numbers because we are making yearly payments, the interest rate is yearly, and the amortization amount, that like the percentage that it's increasing, is also each year. So all of these line up. Keep in mind that if they don't all line up, we may have to adjust to make sure that they do all line up is important. Otherwise, we'll get something inaccurate. Okay, so the first thing we need to do is determine what is the first payment. So let's recall the formula for future value of geometric gradient. That formula states that the future value is equal to the first payment times 1 plus g to the power of n minus 1 plus I to the power of n over 1 plus g minus 1 plus I, which I suppose could just be g minus I if we simplify it. But anyway, that's what this is going to look like. Then we just need to plug in everything that we have and then calculate for A, which is the first payment. So therefore, $750,000 is equal to A times 1 plus g to the power of n. So that's going to be 1.15 to the power of 3 minus 1.1 to the power of 3 over 1.15 minus 1.1. Okay, so next I need to find the coefficient of A by figuring out what this fraction is equal to. So I'm going to grab my calculator and type in 1.15 cubed minus 1.1 cubed equals, and then 1.15 minus 1.1 is 0.05 or 5%. So I'm going to divide by 0.05 and hit equals. And so therefore we have 3.7975 times A is equal to $750,000. So then if we divide both sides by 3.7975, we get 750,000 divided by 3.7975 is equal to, that's going to be $197,498.35. So therefore, that's our first payment. And that might seem like, oh, but that's a ton of money. Is that right? Well, probably yes, because keep in mind that after 3 years, we're going to have $750,000 apparently, according to this. And so that's also a lot of money that needs to be paid off. So that's not super outlandish given the situation. Okay. Next, we're going to start to prepare the amortization table. So the categories we need for our table are going to be the number of years, the period in years, the deposit for the year, also the interest that we made that year based on the previous deposits, and also the previous interest as well, and then the fund balance. So those are the 4 categories here for our table. And let's just draw some lines. Okay, so for years, I'm going to write year 1, year 2, and year 3, because this is only a 3-year thing in this situation. And then our initial first deposit is whatever it was that we found in that last step. which was $197,498.35. And in that first year, our interest is zero because we just deposited this money. We have to wait a whole year before we get interest on it, so $0. So therefore, our fund balance is just what we paid so far, so $197,498.35. Okay, so now let's say a year's passed, it's now year two, and we need to find out how much interest we have now made. So $197,498.35 is our current fund balance, and the interest is 10% per year, so multiplied by 0.1 gives us that the interest we made in year two from the previous balance is $19,749.84. Now, what is our next deposit? Well, the next deposit has to be 15% more than the previous deposit. So I'm going to take that previous deposit amount, which is $197,498.35, and I'm going to multiply that by 1.15 to get 15% more for the next deposit, which that's going to be $227,123.10. And then I'm going to multiply that by 1.15 again to figure out our final deposit, which is $261,191.57. Okay, next I need to find the new fund balance. So basically the new fund balance in year two is going to be the previous fund balance. We still have all the money that we had the previous year, plus we have interest. So we have the $197,498.35 from the previous year, plus we have the interest, which is $19,749.84. Plus, we have $227,123.10. So all of that together is $444,371.29. All right, now how much interest we make in year three? Well, we make interest on the total fund balance, which includes any previous balances, which includes the interest that we earned, includes the new deposit. So we have to multiply that by 10%, which gives us that the interest we make in year three is $44,437.13. And then in terms of finding the new fund balance, we have to add that to the previous balance of $444,371.29 and add that to $261,191.57. And if we do that, we get $749,999.99. So you might say, oh, but this is 1 cent off from the $750,000 you were supposed to have, and that's fine, right? If we're 1 or 2 or even 3 cents off on such a big thing, it doesn't matter. And in terms of how that happened, the way that happened was because we did rounding to 2 decimal places in every step. So basically, it's just rounding error. So that's fine. If it's 1 or 2 or 3 cents different than we're expecting, not a problem. Okay, now we're going to add up the total deposits and also the total interest. So the total for our deposits is $197,498.35 plus $227,123.10 plus $261,191.57. That is $685,813.02. And then as for the total interest, that's going to be 0 plus $19,749.84 plus $44,437.13. That is a total of $64,186.97. And there we go. All right, as always, if you have any questions about any of that, please feel free to leave a comment, and we'll see you for the next one.